In a laboratory in Berlin in 1934, German engineers gathered around the rocket drawings. Vertical launch rockets like a drunken man. Just off, the launcher began to do Brownian motion. At this point, a certain scientist wearing glasses suddenly beat the table. You can give this iron lump installed, a gyroscopic horse will not be dizzy. This crazy idea turned out to be the birth of the amazing device that changed the history of human spaceflight, the gyroscope. When Goddard in 1935 to three-metal gyroscope into the A5 rocket, these tens of thousands of times a minute mechanical device, hard rocket from the drunkard mode, adjusted to straight man walking posture, the rocket from then straight into the air. Later, this technology was later von Braun copywork to improve the achievement of the famous V-2 rocket, so that the Allied air defense forces to see what is the precision strike, but also opened up the era of human spaceflight. The mystery of metal gyroscopes is that they follow one of nature's most stubborn laws, the conservation of angular momentum. Here is a crazy spinning gyroscope. You desperately push it, but it stubbornly maintained the original direction, just like your mom called you dinner when you were still playing the game. Rocket gyroscope inside a high-speed metal rotor when the rocket wants to be lazy crooked neck. Rotor stubborn will drive the shell reverse rotation, and the sensor immediately captured this rebellious signal and then passed this signal to the controller. Then the controller in the guise of a master micromanager. The rudder will be in accordance with the command to adjust the rocket's attitude to the rocket's yaw back. Yaw back. It is this subtle design that allows the rocket to stay straight in the gusty winds. While traditional fiber optic gyroscopes are like hand-rolled building blocks that still require tedious manual assembly, a Chinese research team took a different approach and used silicon-based photonic integration technology similar to chip printing. A team from a research institute in Xi'an has developed a photonic integration chip that shrinks the optical path, which originally required a 2 centimeter square inch to about 4 millimeters, almost 1/5 the size of your fingernail cap. And the key is that the production efficiency is directly doubled dozens of times. This technological breakthrough makes China become the world's fourth independent development of laser gyroscope countries, products covering land, sea, air, and sky. What's more, the Chinese team played a new trick on the DUV lithography. Through innovative optical circuit design and packaging process, successfully compressed the volume of the gyroscope to 1/12 of the traditional products. Zero bias stability has also been enhanced by 30%, equivalent to the abacus beads to make the performance of a smartphone. This integrated laser gyroscope, so that China's tactical missile production capacity to achieve a qualitative leap, now China has realized the vision of precision-guided weapons cabbage. See here, many people may wonder, not talking about rockets? What is the relationship with missiles? In fact, the missile is to say that the addition of the combat part of the rocket is no problem, right?